Statistics, paper 31, mathematics, Monday, 19 October 2020. Answer all questions and ensure that your answers to parts of questions are clearly labeled. You should show sufficient working to make your methods clear. Answers without working may not gain full credit. Question number 1. The Venn diagram shows the probabilities associated with 4 events A, B, C, and D. Write down any pair of mutually exclusive events from A, B, C, and D. So, mutually exclusive events when A intersection C is equals to 0, or probability of A intersection C equals to 0. There is nothing between A and C. They don't intersect at all. A is on the side, that's A there, and that's C. So A and C is one pair. D and B, that's D there. D and B, that's D there in the green, small green circle there. And that's B there. So D and B, and then D and C, that's D there in the green circle, and that's C there. So D and C as well. Given that probability of B is equal to 0.4, find the value of P. When we look at B, everything inside B there, it tells us that everything inside B, the total probability is 0.4. So the total probability in B is 0.4 because that is B there. So we want to find P. So it would be 0.4 minus 0.07 and minus 0.24. So P would be 0.09. Given also that A and B are independent, find the value of Q. For independent events, probability of A and B is equal to probability of A times probability of B. So probability of A intersection B is probability of A times probability of B. So we have probability of A times the probability of B, which is 0.4, is equals to 0.24. Now, the probability of A is Q plus 0.16 plus 0.24 times 0.4 equals to 0.24. So what we want to do, 0.16 plus 0.24 gives you 0.4. And times 0.4 goes to the right, it becomes divided by 0.4. So 0.24 divided by 0.4 gives 0.6. And the plus 0.4 goes to the right, it becomes minus. So 0.6 minus 0.4, it gives you 0.20. Given further that probability of B dash, given C is equal to 0.64, find the value of R. So we're going to use probability of B given A is equal to probability of B intersection A divided by probability of A. So probability of B dash given C is equal to probability of B prime or dash intersection C divided by probability of C. And so the probability of B dash given C is 0.64, is given in the question. Now, probability of everything outside B intersection C. So everything outside B, that's everything outside B, I've shaded there. Everything outside B. And intersection C would be the part that is in C. And that's just R. Divided by probability of C, everything inside C. Everything inside C is R plus P, because that's everything inside C. Now, we know P is 0.9 from part A. So we sub in 0.9. And to solve this, we cross multiply. So you would have 0.64 times R plus 0.09 equals to R. You remove the brackets, 0.64 times R, 0.64 times 0.09, 0.50576 equals to R. Now you take 0.64 R to the right hand side, it becomes minus. Now you factorize, R is common, so it goes out of the bracket. So comes R bracket 1 minus 0.64. It's times there, you take it to that side, it becomes divide. So R is 0.0576 divided by 1 minus 0.64. That gives R to be 0.16. Find the value of S. So total probability is always 1. So that means if you add everything in which I've colored green there, everything which is colored there green, plus whatever is outside, which is called S, that would be 1. So that means Q plus 0.16 plus 0.24 plus 0.07 plus P plus R plus S is equals to 1. Watch this again. Q plus 0.16 plus 0.24 plus 0.07 plus P plus R plus S is equals to 1. Add all of them, you get 1. So let's add all the numbers. Q is 0.20, P is 0.09, so an R is 0.16. We sub in those values, and when we add all these numbers, you get 0.92. So 0.92 plus S equals to 1. So S is equals to 1 minus 0.92, which gives you S equals to 0.08. That's your question 1A. Question 1B and C. Question 1D part 1. And finally, question 1D part 2. Question number 2. A random sample of 15 days is taken from the large data set for Perth in June and July 1987. The scatter diagram in figure 1 displays the values of 2 of the variables for these 15 days. Describe the correlation. The variable on the x-axis is daily mean temperature measured in degrees Celsius. Using your knowledge of the large data set, suggest which variable is on the y-axis. State the units that are used in the large data set for this variable. So we'll describe it as a negative correlation. And we can use rainfall in millimeters, pressure, pascals or hectopascals or millibars. And also precipitation will be accepted. For part C, staff believes that there is a correlation between daily total sunshine and daily maximum relative humidity at Heathrow. He calculates the product moment correlation coefficient between these two variables for a random sample of 30 days and obtaining R is equals to minus 0.377. Carry out a suitable test to investigate staff's belief at a 5% level of significance. State clearly your hypothesis and your critical value. If you want to test whether the population product moment correlation coefficient, rho, is not equal to 0, you need to use a two-tailed test. For a two-tailed test, use null hypothesis is equal to 0 and alternative hypothesis is not equal to 0. And then you can determine the critical region for R for your hypothesis test by using the table of critical values. The critical region depends on the significance level of the test and the sample size. So null hypothesis rho is equal to 0, alternative hypothesis rho is not equal to 0. You need to test for either positive or negative correlation, so use a two-tailed test. Sample size is 30. Halve the significance level to find the probability in each tail. So significant level in each tail 0.025, which you have it for 30 days, and obtain R is minus 0.377, 5% level of significance. Critical value equals to minus 0.3610. So R is less than minus 0.3610. So significant result, and there is evidence of a correlation between daily sunshine and daily maximum relative humidity. H0, there is no correlation. H1, there is a correlation, is two-tailed. So you're comparing minus 0.377 and critical value. You say if humidity is high, amount of sunshine will be low. So support for Starks's belief or claim or evidence of a correlation between sunshine and humidity. Critical values for correlation coefficient. This table concerns test of the hypothesis that population correlation coefficient rho is 0. The values in the tables are the minimum value which need to be reached by a sample correlation coefficient in order to be significant at the level shown on a one-tail test. So if we have sample of 30 at 0.25, you would get 0.3610. On a random day at Heathrow, the daily maximum relative humidity was 97%. Comment on the number of hours of sunshine you would expect on that day. Give a reason for your answer. Humidity is high and there is evidence of correlation, and R is less than 0. So expect amount of sunshine to be lower than the average for Heathrow. Low sunshine less than or equals to 5 hours, and mean for 2015 is 5.3. Humidity 97% is 4.1. Negative correlation, in words, high humidity gives low sunshine. That's your first part of question 2, part A, B, and C. That's the part C and D of question 2. Question number 3. Each member of a group of 27 people was timed when completing the puzzle. The time taken X minutes for each member of the group was recorded. The times are summarized in the following box and whisker plot. Find the range of the times. Find the interquartile range of the times. The range is given by the highest minus the lowest. And the highest is 68 minus 7. 68 minus 7, which gives you 61. Find the interquartile range of the times. The interquartile range is the upper quartile minus the lower quartile. So the upper quartile is 25 minus the lower quartile is 14. So you get 22.5. Interquartile range is different between the upper quartile and the lower quartile. For these 27 people, sum of X is equal to 607.5 and sum of X squared is 17623.25. Calculate the mean time taken to complete the puzzle. Calculate the standard deviation of the times taken to complete the puzzle. So the mean time can be calculated using the formula X bar sum of X over N. Sum of X is 607.5 and N is 27 because there are 27 people. And that gives you 22.5 or 45 over 2. Calculate the standard deviation of the times taken to complete the puzzle. Standard deviation formula we would use, I've circled it. So sum of X squared is 17623.5. N is 27. And the mean that we found out is 22.5, and we square the mean. So we substitute sum of X squared, which is given in the question, 17623.5. N is 27. the number of people. The mean sum of x over n is 22.5, and we square the mean. And that gives you 12.10218, which is 12.1. Taruni defines an outlier as a value more than 3 standard deviations above the mean. State how many outliers Taruni would say there are in this data, giving a reason for your answer. So these are common definitions of outliers. And in exam, you'll be told which method to use to identify outliers. So we've been given that is 3 standard deviation from the mean. So we have the mean plus 3 times standard deviation. So the mean is 22.5 plus 3 times the standard deviation 12.1. That gives you 58.8, which is approximately 59. So numbers which are above 59. And there's only one number above 59. So there's only one outlier. Adam and Beth also completed the puzzle in a minute, in A minutes and B minutes respectively, where A is greater than B. When their times are included with the data of the other 27 people, the median time increases and the mean time does not change. Suggest a possible value for A and a possible value for B, explaining how your value satisfy the above conditions. So median increases implies that both values must be bigger than 0, bigger than 20. So the mean is the same, means A plus B should be 45. So possible values are B could be 21, A could be 24. Possible values for A would be 24 and for B would be 21. Equidistant from the mean, or correct pair of values, both bigger than 20 with a sum of 45. Or their values satisfy at least one of the conditions, bigger than 20, and they add up to 45. And note, the values of A and B do not need to be integers. The values for A and B do not need to be integers. 3G. Without carrying out any further calculations, explain why the standard deviation of all 29 times will be lower than your answer into part D. Both values will be less than 1 standard deviation from the mean, so the standard deviation of all 29 values will be smaller. So you must mention that both values are less than 1 standard deviation from the mean. Both values are less than 1 standard deviation from the mean.